Hello guys, you welcome back to O1 Tutor. In these videos, we are trying to spread the awareness on many different topics so that our students would know what interests them the most, so that they can pursue it in the future. Based on the votes of the story that we posted on Instagram, we decided to start a new series called Strategy, and in this series we are going to present different videos regarding the world of strategy. Now, you might think that strategy doesn't have a science behind it, doesn't have numbers, it doesn't have mathematics behind it, but this video will show you that indeed the world of strategy is defined by a science, right? It's defined by numbers and by proper analysis that would yield certain decisions in our everyday life, and especially in the business world. So the first episode is going to be about a very interesting topic in the world of strategy. It's called the game theory, and the game theory is best explained by what we call the prisoner's dilemma. Now, to explain this video, let's suppose that we have two convicts that were caught red-handed by a police officer, right? So in here you have the both convicts in here, so the convicts are represented in red, and the police officer came and he caught these two convicts red-handed, meaning they have committed a crime. But the police officer doesn't have enough evidence to put the blame on one of them, so he took both of them to the police station, right? He took both of them to the police station, and he put every one of them, he put each convict in a separate room, okay, so that they cannot have any contact with each other. So he puts convict A in this room, and he puts convict B in this room. And what he did is that he offers each one of them a certain deal, okay, a certain deal that would reduce his sentence in prison. So what the police officer did is that he offered each one of them a reduced sentence if he testifies against the other. And the results of this experiment can be visualized by the following table. So if we put a table in here, right, if we put prisoner number A in here and you put prisoner number B in here, so let's make the table bigger. Okay, so in here you have A, and in here you have prisoner B, and there is one of, for each prisoner there is one of two choices. For prisoner A, there are two choices: either he testifies against B or he doesn't testify against B. So let's put in here testify. Same thing goes for prisoner B, in which he has two options: either testify against A or not testify against A. Now what's gonna happen is the following: if both A and B testify against each other, both of them will get 3 years in prison. So in here 3 years for both, right? 3 years for both A and B. Okay. However, if B doesn't testify against A in the separate room that the police officer is talking to B, right? A and B are not allowed to talk to each other. So if B doesn't testify against A, but A testifies against B, the result would be that A goes for free. So A has 0 years. A has 0 years, but B would have 10 years. B has 10 years in prison. And the same thing goes for, the reverse thing goes for the case where B testifies against A and A doesn't testify against B, right? If B testifies against A but A failed to testify, this means that what happens is gonna be that B goes for free, so B has 0 years, while A in here would have 10 years. So A has 10 years of prison. Okay? And the final case where if both of them did not testify against each other, what's going to happen is that the police officer would not have enough evidence to put them both in prison. So what's going to happen is that they both would have 1 year of prison. So in here, they would have 1 year for both. So this is the experiment, right? So remember that the two convicts are put in separate rooms and they are not allowed to talk to each other, so they wouldn't be able to, talk to themselves and say that it's better for us not to testify against each other because we will reduce our sentence to 1 year for both. Now, if you look at this table, it seems in the best interest of both prisoners not to testify against each other, because then they would have both a 1 year of prison. But according to the prisoner's dilemma and according to the game theory, this is not the case. This is not what's going to happen in the case of this experiment. Because although it seems to us that the best interest of both prisoners is not to testify against each other, let's consider the case for each one separately. Okay, so let's consider the case for A and B separately. Okay, so each one of them alone is faced with two options, right? Is faced with two options, either to testify against the other or not testify against the other. Now, let's look at the table above and try to formulate the table for each one separately. If A testifies against B, he has one of two choices, right? He has one of two possible results. If A testifies against B, he can either take 3 years. Okay, if A testifies against B, he can either take 3 years if B testifies, or he can take 0 years if B doesn't testify, right? So if A testifies, he has one of two possible options, either 3 years or 0 years. However, if A doesn't testify, meaning we're looking at, the second row in here. If A doesn't testify, he either will do 10 years of prison. So in here you have 10 years. Okay, and the second one would have 1 year. Okay, right? So this is from the perspective of A, and it's the same thing if you look at the perspective of B. Now, from the perspective of A, he is faced with two possible choices: either 3 years or 0 years, which is represented by the first case, okay, of him testifying, or 10 years and 1 year, for the case of him not testifying. And from the perspective of A, 3 and 0 seem like a better deal than 10 and 1. So no matter what B does, the game theory tells us that A would testify, even though if both didn't, they would both get the minimum sentence, right? But from the perspective of one of them, okay, assuming that both prisoners are rational, they are acting upon their rationality, they're not acting upon emotions, and assuming that both of them are not allowed to talk to each other, what's going to happen is that the final result would be that they would both testify against each other. Now this helps us get to a very important conclusion in the game theory, which is that two humans, assuming that they are completely rational, would choose the option that is not in their best interest, because they fail to cooperate. And this state, which is the final result, so what the game theory says is that what the prisoner's dilemma says is that the result would be in here, okay, is that A and B would both get 3 years of prison each. And this is a state called Nash equilibrium, relative to John Nash, okay, who contributed to the game theory and who came up with this conclusion, right? It's called the Nash equilibrium, and you can watch a movie called A Beautiful Mind for John Nash. It's a kind of biography to this great mathematician that contributed a lot to differential equations and to the game theory. Now, another real-life application of the game theory applies to Apple and Android. Usually we refer to Apple and Android also when we talk about game theory. Now we know that, suppose that Apple and Android have a monopoly on the market. Okay, they have a monopoly on the market. Now we know that both of them spend a huge amount of money on advertising. Although if this money spent on advertising was spent instead on research and development, we would have much better phones. But why would they both spend on advertising, although this money can be invested otherwise? Because if Apple doesn't spend on advertising, it has a fear that the competitor, which is Android, would take market share. Okay, however, if both do not spend on advertising, if both Apple and Android do not spend on advertising, both of them would be better off by investing in research and development so that they can upgrade their products, right? But again, they would still operate on Nash equilibrium, on a state that is not in the best interest of both, okay, which is spending on advertising in the fear of the other one, grabbing a more market share than the other. Okay, so again, one small thing before we finish up this video: if you watch The Dark Knight, which is the Batman, not the Dark Knight Rises, it's the second one, the one with the Joker. Okay, The Dark Knight, the one with the Joker, you would notice a scene where the Joker plants 2 bombs in 2 separate ships, one for convicts and one for for non-convicts, and he gave them two options, in that if one of them blows the ship of the other, then this one would go for free, right? So this is also a direct application of the prisoner's dilemma, but the end result in the movie, in The Dark Knight, would be that both would cooperate. So it would be like, you know, a counter example of what John Nash said, in that the movie shows us that both of them would not blow each other, and then both of them would live. So this is a counter example of the Nash equilibrium, because the Nash equilibrium says that one of them would blow the other just to survive, because it's better off, you know, from the perspective of the people who are on either ships. It's better if they blow the second ship so that they can survive. Okay, but you know, the movie shows us other ways. So you can check these two movies out. One is called The Beautiful Mind, and the other is called The Dark Knight. There is this scene of bombs and chips where you can see the direct application of game theory. So I hope you enjoyed the video, and I will see you soon in the next video. Hopefully the next video is going to be on number theory. We're going to continue with prime numbers and the world of congruences and residues. I will see you soon.